Didn't make the noise, but I think it's going. All right. So we're going to start talking about logarithms. So like I said, it's brand new, but today's lesson, if you'll just give me your attention for like 15, 20 minutes, everybody's going to be able to do this for sure. So this topic is going to be called 7.3, Intro to Logarithms. All right, so a logarithm is going to be written with the word log. And so here is an example of what a logarithm is going to look like. It has some variables on it. Normally there's numbers, but you would read this one as log base b of a equals x. And a logarithm is just another way of writing exponents. So you might wonder, like, why do you need another way to write exponents? You will. There'll be some equations like we solved yesterday on the quiz that you won't be able to rewrite with the same base. You have to use logarithms to be able to solve them. So what I like to do whenever I'm changing back and forth from logarithmic form to exponential form is do this loop. And so what you do is you start with the base. Oops. And you're going to loop around to the x and then back to the a. That's the order that you're going to write the numbers or variables in when you write in exponential form. So you start with the base, which is going to be a big base in exponential form. And then that base is raised to the x. And then as we keep looping around, that's going to equal a. Right? So the answer to a logarithm is always the exponent. All right, so one of the things we're going to do today is go back and forth between these two forms. All right, so we're going to start on these, and we have logarithmic form. We're going to write them in exponential form. So if you like the loop, you can draw the loop. So you start with the 3, loop around to the 2, and back to the 9. So in exponential form, this is 3 to the second power equals 9. Is that true? Yeah. So when you write in exponential form, you can kind of check in your head to make sure it really works out. All right, let's look at another one. So for number 2, if you draw the loop, you would start with the 6. And so that means 6 to the third power is 216, which is also true. The chart that I gave you a few days ago, that might come in handy a little bit today, later on. All right, I'm going to do one more with you, and then I'll let you guys do some on your own. So you can draw the loop on number 3 if you want to, but you would start with 7 raised to the 0 equals 1. Is that true? Mm-mm. Everything except 0 to the 0 power is 1. Yeah. All right, so I want you guys to try 4, 5, and 6 on your own, please. All right, so check yours with mine whenever you get finished. Just make sure everything's all right. All right, and then we're going to do it the other way as well. So on 7 through 12, they're written in exponential form, and we're going to write them in logarithmic form. So when you write in logarithmic form, you always have to start with the word log. And then you fill in all the parts. If you like the loop, you can draw the loop again. You would start with 14 and loop around. Now, when you write in logarithmic form, the base is a subscript. So it's a little smaller, a little lower than the log. So it'd be log base 14 of 196 equals 2. Good. All right, so when we go to do number 8, we're going to start with the word log. And then you can draw the loop if you like it. All right, so log base 3 of 81 equals 4. So it helps to remember that the logarithm always equals an exponent.
Whenever you use like fractions, like 11,
Mm-hmm.
is it still 1/8 equals -3?
Yeah. Log. Well, we can skip and do number 11 if you want to. It would be log. And then you sweep around. So log base 2 of 1/8 equals -3. That's how you do that one. All right. So you guys try the 3 that we hadn't done already. So 9, 10, and 12, please. All right. Check the ones I wrote in green if you haven't already. All right, there are 2 special kinds of logarithms. One of them we're going to talk about today, and then another one I think it'll be next week before we talk about it. But log base 10 is so common that it's called the common logarithm. And I think it's because our number system is in base 10. But another one that you'll see a lot is also log base 2, but it's not a special one. I think that has to do more with computer science. But if you ever see a log without a base, it's log base 10. So they can represent log base 10 with a 10, or it could just be log of x. Those mean the same thing. So if you ever see a log with no base, the base is 10. All right, so on the back, we're going to evaluate some logarithms. And the answer to a logarithm is always an exponent. All right, so if we were going to do number 13 in our heads, then we would ask ourselves, 7 to what power gives you 49? And this is where that chart might come in handy if you want to use it. But what do you guys think? 7 to what power gives you 49? Well, 7,
Wait, no, I'm wrong.
it's like how many times would you multiply it by itself to get 49? 7 times itself 7 times? Just 2 times. So 7 squared is 49. 7 times 7 is 49. That's what 7 squared means. I think you guys were adding.
Got 7.
Yes, 7 times 7 is 49. That means 7 squared. All right, if you're not good at squares and cubes or whatever, use this chart. It'll be helpful. All right, then for number 14, if we are trying to figure the answer to this logarithm, we would ask ourselves, 3 to what power gives you 27? So how many times would you multiply 3 by itself to get 27? Not add, multiply. 3 to the third. 3 times 3 is 9 times another 3 is 27. Make sure you're multiplying. If this doesn't make sense to you, you're not multiplying, you're adding. I promise you, 3 raised to the third power is 27. That's what we're looking for. 7 squared is 49. All right. Now 15 doesn't have a power. Just kidding. 15 doesn't have a base. What's the base if there's no base? 10. So we ask ourselves, 10 raised to what power gives you 100? 10 to the 10th is 10. 10 to the 2. You guys just aren't answering the question I'm asking. 10 raised to the 10 is 10 times itself 10 times. So it's actually a 1 with 10 zeros. But 10 raised to the second is 10 squared, 10 times 10, which is 100. So the answer is 2. If there's no base, it's base 10. So that's the common logarithm. So a log with no base is base
10. Can we write it like 10 squared equals 100, or do you want us to like?
At some point, you need to tell me equals 2, equals 3. The answer to the logarithm is only the exponent. Okay, this next one is kind of tricky. Yeah, you're going to ask yourself 12 to what power gives you 1? 0. Everything except 0 to the 0 power is 1. Okay. Number 17, you would ask yourself 2 to what power gives you 64. Now, even if you were using the chart, it doesn't go all the way to 64, but 2 to the 5th power is 64. Is 32. So it would be the 6th power. 2 times itself 6 times is going to be 64. All right, and then 18. 3 to what power is 343? 243, I should say, and it is the 5th power. And that one is on the chart. So you just go in that 3 row and you look all the way to the end and you get 243, and so it's the 5th. All right, the next two are kind of tricky. I'm actually going to change number 20 a little bit. So if you're working ahead, hold off on number 20. All right.
Do you have any more of those papers?
So on number 19, we want to know 9 raised to what power, you're welcome, gives you 1 over 81. Good. So I know if it changes to a fraction, it's a negative power. And then 9 to the second gives you 81. So 9 to the negative second would be 1 over 80. All right. And then this one I'm going to change to 16. The base is 16. I think we can figure it out. 64 is, I just don't want to do it that way. Okay. So we're going to figure out 16 raised to what power gives you 4. Okay. 16 to the second power is 16 times 16, which is 256.
Simplify. Like do that thing like we did the other day.
I don't think so.
Oh,
it would be a fraction. What type of root do you take of 16 to get 4? The square root. And so what exponent means square root? Not 2. It is a fraction. 1/2. Good. So that's going to be 1/2. All right, now I know I told you guys this is super easy, and some of those were not super easy. So your calculator will do every one of those problems for you. I want you to be able to do them in your head because I want you to understand what a logarithm means. But the calculator is amazing with logarithms. So I meant to change the notes before I printed them, but I didn't. So all this change of base, we're not going to do. So you can just mark it out. We're not going to do change of base. We're going to do something else. The calculator didn't used to do what it does now. All right, so what we're going to do to get a logarithm in the calculator is hit alpha. And then window. And then we're going to choose number 5. And you'll remember it because it says log base. All right, now a couple of these we could figure out in our heads, but we're just going to do these bottom 6 in the calculator. All right, so remember we do alpha, window, and then we're going to choose number 5. So everybody type that in, alpha, window, 5. All right, and then this thing comes up, and it's fairly obvious what you do. If we were doing number 21, we would just put in 16 for the base, put 64 in the parentheses, and it does it all for you, and it's 1.5. All right, if we wanted to do number 22, same thing, alpha window, choose 5 for log base, and just fill it in. Now, a lot of these don't come out even, like 1.5 came out even. So we're going to round to 3 decimal places. So we'll do 1.667. All right. So you guys type the rest of those 4, please, in your calculator. Was it decimal?
Yeah.
There's not an exact number you can raise it to. It's not multiple. The last one the number 26 we probably could have done in our head. We definitely could do in our head. It's just like number 19. Oh, I've got my numbers wrong. I switched them on this one. All right. What questions do you guys have on logarithm? I told you can all do it. All right, let me give you guys your assignment.